I don't think people appreciate how big astronomically large numbers are. Suppose I had 100 billion $1 bills. What can I do with 100 billion dollar bills? Well, I can take them and put them end to end, and I can go around the earth 200 times. But I have some leftover money. So now I'm gonna put them vertically and see how high they go. Well, with what's left over after you went around the world 200 times, you can go vertically to the moon and back 10 times. So let's go up by another factor of 1,000. From a billion, which is 9 zeros, to now we go to 12 zeros. 10 to the 12th power is a trillion. About 1 trillion seconds have passed since cave dwellers painted on cave walls. Here's why that's significant. Because you can actually count to 1 billion in your lifetime. You live your billionth second between your 31st year and your 32nd year of life. So how long will it take to count to 1 trillion? It's 1,000 times that. So you need 1,000 times 31 years to get there. How long is that? 31,000 years. Let's go up another factor of 1,000. So what would be the next number? Quadrillion, and that has 15 zeros. That's 1,000 times bigger than 1 trillion. About 100 quadrillion, I calculated this, is the estimated number of sounds and words ever uttered by all humans who have ever lived. Let's go up by another factor of 1,000. Quintillion. So that's a 1 with 18 zeros. That's about the number of grains of sand on an average beach. Let's go now 1,000 times bigger than a quintillion. So quintillion was 10 to the 18th power, 1 with 18 zeros. Now we're talking about 1 with 21 zeros. Sextillion. That is the estimated number of stars in the universe. So that's 1,000 times larger than the number of grains of sand on a beach. But let's keep going. 10 to the 23rd power. You met that number in your chemistry class in high school. 6.02 times 10 to the 23rd power. That's a mole in chemistry. And a mole is how many particles of a substance occupy a specified mass of that substance. Do you realize there are more molecules of water in a glass of water than there are glasses of water in all the world's oceans? Not only that, there are more molecules of air in a single breath of air than there are breaths of air in all the world's atmosphere. What this means is when I drink a glass of water, and then it comes out of me 7 different ways, it goes back into the environment. There are enough molecules that I have just expelled to repopulate all the world's water supply with some of the molecules that were in the glass that I just drank. If you can get a character from long enough ago, whoever your hero is it Socrates, is it Joan of Arc, is it Jesus, in the glass of water you drink, there is water molecules that pass through the kidneys of Jesus. There are air molecules that were breathed by Genghis Khan. And so in that way, we are deeply connected in the fluids we consume and in the air we breathe. So working up from the mole, we get to 10 to the 81st power. If you multiply all the stars and times all the molecules and particles they're made of, you get 10 to the 81 power, which is the sum of all particles that comprise the observable universe. So there's a number, a 1 with 100 zeros, nice round, that would be 10 to the 100th power. That's called a Google. The company took that word, messed up the spelling of it, and they became the first time most people even ever heard the pronunciation of such a thing. Google. Nice. How about a number that dwarfs the Google? That's 10 to the Google power. Is a 1 with a Google zeros, and that's called the Googleplex. Here's the problem with the Googleplex. How many zeros does it have if you were to write it out? 10 to the 21 had 21 zeros. 10 to the 81 had 81 zeros. 10 to the 100th, Google has 100 zeros. 10 to the Google is a 1 with a Google zeros. That's a Googleplex. If a Googleplex has a Google zeros in it, there are not enough particles in the universe upon which you would write the zeros just to express that number. Why do you have big numbers at all? Because you're no longer counting things, you're counting events. So for example, there is a number that dwarfs the Googleplex. It's called Skew's number. It's 10 to the 10th to the 10th to the 34th power. It's the number of combinations of particle configurations in the universe. There you have it, the cosmic perspective of big numbers.
If you enjoyed this video, let us know what you think in the comments section below. Also, kindly subscribe to this channel and hit the like button. Thanks for watching. See you in the next video.